Hello, welcome to the video for Chapter 6, Lesson 8, Right Triangle Trigonometry. This lesson's essential question is how do we use the relationships between the sides of right triangles to find missing angle measures and side lengths? Before we get started, I strongly encourage you to check out this YouTube video. It has a great introduction to what the trig functions are to begin with. This lesson will focus on how we use those trig functions, but this YouTube video does a great job explaining what they are to begin with. Now let's get some vocabulary, and we'll start with theta. Theta is a variable used to represent an unknown angle measure. We will use that unknown angle measure, theta, to label the parts of a right triangle. So in reference to this angle, whatever it is, it's a variable. We don't have to know its measure. We are just going to use this angle. The opposite side would be directly farthest away from that angle. Adjacent side would be next to it. And the hypotenuse will always be opposite the right angle every single time, no matter where theta is. So when we look at moving theta, if we put theta down here in this angle, then the opposite and the adjacent actually switch. The hypotenuse stays the hypotenuse no matter what, because it will always be the side opposite the right angle. It should always be the longest side of the right triangle. And again, if you notice, when theta moves, your opposite and adjacent sides also change, and that will be important as we begin to use these trig functions. And there are three main trigonomic functions: sine, cosine, and tangent. Sine, cosine, and tangent are the full trigonomic functions. Those are the full words, but when we write them out and when we see them on our calculator, they are shortened to sin, cos, and tan. We are still going to pronounce this word sine, not sin, because it is referencing this word. And cos, I just always say cosine, and same thing with tangent. I just continue to say the full word. Ultimately, that's up to you. I just stress the importance of not calling this sin. It is sine. So these are ratios. So they're going to be fractions, and you're going to be using the sides of the right triangle that we just mentioned: opposite side over the hypotenuse, adjacent side over the hypotenuse, and opposite side over the adjacent. And this will always reference that theta, that reference angle that you are choosing. So the opposite side over the hypotenuse is the ratio for sine, adjacent over hypotenuse is the ratio for cosine, and opposite over adjacent is the ratio for tangent. And you do have to memorize that, and so one way to do it is this fun little saying of SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first set of examples, all we're going to do is figure out what the three trig functions are. And so that's just going to be filling in the opposite over hypotenuse for the sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. So those sides will be identified based on the angle that you are referencing, and in this case it's this theta over here. So opposite side would be the 12, the adjacent side would be 35, and then we have to do some work to find the length of the hypotenuse. We'll just have to use the Pythagorean theorem. Once we have the length of the hypotenuse, we're just going to fill in these fractions. After doing Pythagorean theorem, the length of the hypotenuse is 37. So opposite over hypotenuse is 12 divided by 37, adjacent over hypotenuse is 35 over 37, and opposite over adjacent is 12 over 35. And again, these numbers are just coming from the sides of the right triangle. So in our calculators, we just enter in this division. So the sine of theta for this triangle is 0.32, the cosine is 0.95, and tangent is 0.34. Whether or not you leave them as fractions or decimals will ultimately just depend on the instructions for each problem. Generally, I will just go ahead and use the decimals. So once again, all this really is doing is finding the ratio. We are just plugging in with our opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So taking a look at this second problem, we needed to do some work to figure out this adjacent side to theta. So again, theta is our reference angle, opposite's going to be the 15, adjacent we had to find using Pythagorean theorem, and the hypotenuse is opposite the right angle, so that's going to be a length of 17. And again, with these, when we're just finding the trig ratios, all you need to do is plug in following those fractions: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Entering these divisions into your calculator, these are the ratios. This final example here is not any different than the other two, except instead of using theta, it's identifying the angle using the vertex. So in this case, angle B, this is the vertex here, this would be using this angle to reference your opposite, adjacent, and hypotenuse. The work is still the same. We had to do some work to find the adjacent side using the Pythagorean theorem. Then we just use the ratios for sine, cosine, and tangent, and divide to get the decimals. There are now 2 problems for you to do on your own. Please go ahead and pause the video before moving on and checking your answers. One of the types of questions I'd like you to be able to answer using trig functions is actually finding angle measures. And so finding these angle measures, we're actually going to figure out using only a right triangle, and we only have 2 sides given. How can we figure out the actual measure of angle x and the measure at angle z? And we're going to use our trig functions for that, because we can use our opposite, hypotenuse, or adjacent and hypotenuse to figure out the missing angle measure. So for the measure of angle x, the 4 is the opposite side and the 5 is the hypotenuse, so the sine of x is 4/5. Now in the previous problems, this would just be the trig ratio. The ratio of the sine of x is 4 out of 5. But I actually want to use this to figure out the value or the degree for that angle. So we're going to use inverse functions. Now, all that means is in your calculator, you have to hit the second button first. So you hit second and then sine, 4 divided by 5, and hit enter. So second sine, 4 divided by 5, and hit enter, and you'll have your angle measure. And then we can do the same thing again with z, but now with z being a reference angle, the 4 is now the adjacent side, 5 is still the hypotenuse. So since now the 4 is the adjacent side, we have to switch our trig function to the cosine. So if this were a problem where you were just finding the ratio, then the ratio is 4 over 5. But we will use that along with the inverse function to figure out the actual angle measure. So again, in your calculator, you're hitting the second button, cosine button, 4 divided by 5, and hit enter, and you'll get 37 degrees. You will want to make sure that the 90 and 53 from the last problem and the 37 should all add up to 180 degrees inside the triangle. Taking a look at another example, angle A, the 5 is the adjacent, 13 is the hypotenuse, so we will use the inverse of cosine to figure out the measure of angle A is 67 degrees. Switching to B, B as the reference angle makes 5 the opposite side, 13 is the hypotenuse, so we will use the inverse of sine, 5 over 13, that's opposite over hypotenuse, to get the angle measure of 23 degrees. You have a couple problems to do on your own here. Please go ahead and pause the video, take some time to use your inverse functions to find the missing angle measures. The second type of problem I'd really like you to be able to use trig functions for is finding missing sides. Missing sides, looking at our right triangle, normally with missing sides of a right triangle, we would use Pythagorean theorem. But in this case, I only know one given side. I'm trying to find one specific side, and I don't know what this side is down here, so I don't have enough information to use Pythagorean theorem. Luckily, I have an angle measure that will allow me to use trig functions. So using the given angle measure as my reference angle, the x is the opposite side, and the 25 is the hypotenuse. So in purple, my original function, my original ratio is the sine of 40. It's not an x, it's not a theta. I know it's 40 degrees. So the sine of 40 equals x over 25. What you need to remember here is that the sine of 40 is a number. It's some crazy decimal. So when you're solving for x, all you have to do is undo this division over here by multiplying both sides by the denominator. So I'm going to multiply both sides by 25. You type this in your calculator, 25 times the sine of 40, and x will equal 16.07. I just rounded it to 16 just to have nice sides of a triangle. In this next example, I'm given 47 degrees. I'm given x on this side and then 35 over here. So it looks like I'm missing the hypotenuse. So I'm given opposite and adjacent. So I'm going to use the tangent function to figure out the length of x. So tangent of 47 is opposite over adjacent. Tangent of 47 is x over 35. Solve this purple equation by multiplying both sides by 35. Type this in your calculator and x equals 37.5. Now there are 3 problems to do on your own, but this first triangle is a little bit different than the ones we've been doing so far as solving goes. So I would first like to do this one with you, and so then you'll be able to do these 2 on your own. But we're going to take a closer look at this one. So in this particular triangle, the 46 degree is the reference angle, opposite over hypotenuse. We get this trig ratio, sine of 46 equals 8 over x. If you notice, this ratio is different because in the other problems, the 8 would have been in the denominator. So solving it, my steps are still going to be the same, but it's going to look a little weird because I have to multiply both sides by x first. So I get x times the sine of 46 equals 8 because these x's divide out. Now, again, remembering that sine of 46 is just some number. I just need to divide both sides by that number. So divide both sides by sine of 46. And this is what goes in your calculator. So you need to type into your calculator 8 divided by sine of 46, and that's what will give you the value for x. X equals 11.12. So ultimately, you have 2 types of problems when you're solving for side lengths. You either have problems where you're going to take a number and multiply by sine of 46 or sine of whatever the angle measure is, or you have these situations where you might divide. It's very important for you to set up your original trig ratio correctly so that way you know if you're really going to be multiplying the numbers or dividing the numbers. Another type of question you might be asked to do is to solve the triangle. Like the question will simply say solve the right triangle. And when it's asking you to solve the right triangle, what it really wants you to do is identify all 3 side lengths and all 3 angle measures. And you might have to use trig function or Pythagorean theorem to get there. So angles will often be the easiest because with the angle measures, you are most often given the most information. So I have 54 degrees, I have 90 degrees, so I can quickly take 180, subtract 90, and subtract 54 to figure out that the angle measure is going to be, 36 degrees. So this is 36 degrees right there, and my angle measures are 36, 54, and 90. And so all 3 of my angle measures have been found. When I do the sides, this 7.1 is what we already found on the previous. This is just the one that you found with x. I'm going to go ahead and label this side over here as y. I'm going to use the y as opposite, the 12 as the hypotenuse, and I'm going to use sine of 54 equals opposite over hypotenuse, and I'm going to multiply both sides by 12. And that's going to give me my value for y. Y equals 9.71. So my 3 side lengths are 7.1, I'll just make that 9.7, 7.1, 9.7, and 12. So 7.1, 9.7, and 12. And now we can call this right triangle completely solved because I know all 3 side lengths and all 3 angle measures. This concludes the video for Lesson 8, Right Triangle Trigonometry. So how do we use the relationships between the sides of right triangles to find missing angle measures and side lengths? We identify the reference angle and use SOHCAHTOA, sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent, trig relationships.